All right, so let me start the session. Welcome everyone for the webinar series, Computational BIM for our Archicad now. So today is session 2. On the first session, Dinesh was showing how to establish the connection between Archicad and Grasshopper, and we were also doing some testing. And last week we sent out some assignments to you guys to follow. Maybe we will touch up on those assignments today in this session, and then we also have other exciting things to see today. Okay. All right, so today we are going to see the Grasshopper user interface, and then we'll be seeing the assignment that we have passed to you guys to do last week, and then we'll be seeing the sun shading device example and how it changes the orientation or the sun shading device orientation based on the sun's azimuth angle. Okay, so we are going to see that today. As I told, we will also be seeing the learning resources, the user interface, assignment example, and the sun shading devices today. So the learning resources to learn Grasshopper and then its connection with Archicad. The first thing we want to mention is the Grasshopper LinkedIn Essential Training. You can scan the QR codes here and then reach the tutorials or the learning materials there. So the next thing is the Grasshopper Generative Design specifically for architecture. So that is also available in LinkedIn. So this essential training is about 6 hour training, and this is about 3 hours, if I'm not wrong. And then we are also happy to show this website or also the ID, LinkedIn ID, Mohammed Yazdi, the person who shares the code with you guys to download in the activities. So you can just go to his page and then check his activities. So you can just scan the QR code from here and then check his activities where you will have multiple examples that he has implemented using Grasshopper along with the codes which you can download and check if you want. So that is for you guys. And then the Grasshopper primer website is basically the manual for Grasshopper that you can start with. So you can just scan the QR code and then use the manual if you want to read and then do things. And then we also have a playlist in Graphisoft website where it shows the connection between Grasshopper and Archicad. There are some examples and also the tips and tricks available. So the next is thank God it's computational website. So you can scan the QR code and then the website also has a lot of examples which shows the workflows between Archicad and Grasshopper. Some of the workflows we are using Grasshopper, you can automate your processes. So that is available on this website. So please watch those tutorials, or there are some webinars and some blogs available. You can just watch and get benefited. So these are some of the learning materials that we suggest you guys for you to learn Grasshopper and then the Archicad connection, how to implement parametric design in Archicad. Okay, so let us go to the Grasshopper UI, then see how Grasshopper looks and then how we can use it to create the parametric design inside Archicad. Okay. All right, so if you see this, this is the Rhino interface. You can see from here, just like any other tool, we have menu bar, toolbar, and then the tools on the side. Here we have the settings, and we also have different views: top, front, right, and perspective. So if you double click the perspective, it will just show it. And then here on the comment box, you can type Grasshopper. Once you type Grasshopper, the Grasshopper interface will be open. Just make it bigger for you guys. Okay, so this is another tool using which you can place all the nodes and then communicate with Archicad. Okay, if you see here, we have the menu. Uh, Let me just show you the display for now. Under display, we have draw icons. So when you switch on this draw icons, so when I drag and drop the components from the toolbar, components bar there, so you can see all the components are showing the images here or the symbols here. So if I just switch it off, you'll be able to see the names there. So for today, I'm going to have it as names so that whenever you guys follow the video later, you'll be able to just see the name and then you can just double click inside the canvas and then search. Maybe let me just search the point and then you can see point. you can just bring it inside without going and dragging and drop it from here. Okay, you just delete these, select all, and then you should be able to delete it. Okay. All right, so I'm not able to delete this. Okay, now we'll just create a new file later. So I just wanted to show the components here. So there are different tabs, component tabs here: params, maths, sets, vector, curve, surface, mesh. And if you have installed the Archicad connection, so you'll also find Archicad tab here. So inside which we have multiple components here. Okay, so here you can see the settings, the parameters. Parameters are basically to choose the components from there and then bring in that geometry inside Grasshopper. Okay, and there are some input components. We have extract settings. So whenever you bring in the components from Archicad, you can extract the settings of those components and then use them for the new components inside here. Okay, so there are also design basically to create new components from Grasshopper inside Archicad. So for example, if I have to create a beam, just drag and drop the beam here, and then I need to pass the curve of the beam so that it will create a beam inside the Archicad. So if I have the settings for the beam, so say for example from here, if I bring in the settings here, I can just pass the beam settings inside so that it will create a beam when I pass the curve with these settings. Okay. All right, so there are a lot of component tabs here. So let me just show you the first one, params. So inside here, we have input, which we often, very often use. The number one, the first thing that we very often use is the number slider. So here, if you see, I'm just dragging and dropping it here. And then under the number slider, I can change the name here. Say, for example, if I want to have the beam length or something, I can just change it here. And then you can have it as a real number or a integer number, which is the natural number. So I just make it natural number. So I can give a lower bound, which is 1, and I can give a maximum bound of 20 or something. So then now the range is also 1. So if you see here, I'll be able to move or slide this one by one until 20. Okay, so this is very useful when you're trying to control your design with number slider inputs. Okay, and then we also have panel, which is very often used to basically check the results of any of the components. So here, if you see, when I collect this beam length with the panel, you can see I can see the number 20 here. Okay, so if I change the slider, you'll be able to see whatever you have inside, whatever it's the output from the previous node. Okay, all right, so we also have Boolean toggle. So Boolean toggle is basically true or false. So I can just double click to change to true or false. And then even if I connect it to the panel, you'll be able to see the results. So panel is most probably to enter some of the text inputs or to check the outputs of any of the components. Okay. We also have a button. So basically you need to just keep it pressed if and then to activate it. And then if you release it, it is deactivated. And then we also have value list here. Okay, so if you go here, so there is 1, 2, 3, and 4 options now. So like I can change it to 3, and I can see under, yeah, if you just right click here, you can change the name, and then if you go to edit, you will be able to see the values that are coming out of these options. So for 1, the value is 1. For 2, it's 2. For 3, it's 2 squared minus 1, which is very complicated. Maybe you can just make it 3 or 4, and click OK. You can send it to the panel and check the results here. So based on the options that you choose, you can output a value that is inside this list. Okay, so I can even change this to maybe 10. If the user chooses 4, the output will be 10. So these are some of the inputs that you might very often use in your code. Let me show you some other examples here also. So here there are points which I showed earlier, and we also have circle, curve, plane. BREP is basically the geometry, boundary representation. Geometry of any component is the BREP. So we might also use that. We might also use rectangle sometimes. We might use geometries. So these are some of the basic things. And under curves, we have you know endpoint of a curve. You can just connect it to a curve and then get the endpoints of the curve. And if you want to create a curve or a line, you can just use this line tool and then input the start point and an end point. It will give you a line there. Okay. So the next thing is divide curve. So whenever you have a curve, you can pass it inside and then pass the count inside here, and then you will be able to get the divide curve. So maybe we'll be using it today in one of the examples. I'll show you in detail in that one. Okay, so this is how we can place all the components inside here, and then you can connect it. So by connecting it, you'll be able to create your recipe for this Grasshopper code, and then you can implement your design ideas there. Okay. Okay, let me just close this and then create a new file. All right, so whenever you're creating, just make sure you're using large objects meter. Okay, now let's go and create or check out the assignment that has been passed to you guys. Okay, so let me go back to Rhino here. Okay, so let me open Grasshopper. All right, so let me just make my screen smaller so that it is easy for you guys to just check out everything in one screen. Okay, so here is my Archicad. So let me just delete this. Okay, let me just start the connection first. Okay, starting the connection, go to File, Interoperability, Grasshopper connection, and then you can start the connection here. Once you start the connection, you can just go and draw your polyline as given in the assignment. So just use the polyline tool under the document toolbox, and then I'm going to use the square method to create my geometry. Okay, so for that, select a starting point, and then the in the document on the assignment it was told to have 12,000 by 12,000 polyline. Okay, so you have the polyline here. What you can do is just keep it aside and then come here inside the Grasshopper. You can go to Archicad, and then I want to bring in my polyline from Archicad inside the Grasshopper. So for that I'm going to use the parameter 2D curve here. So under Archicad, parameters, you will find the 2D curve. Okay. All right. So when you place the 2D curve, what you can do is you can right click and then set one 2D curve in Archicad. Okay. So it will let you choose the 2D curve in Archicad. Okay. Let me just try to make it small again. All right, so you can see that the warning has been released. So now there is no warning, it's just gray in color. So now you can use this 2D curve and then convert it into a Rhino curve. Let me just convert this into a Rhino curve. So for converting, just bring in the curve component here from the parameters and params and then just connect it. Okay, so inside Rhino, we'll be able to see the Rhino curve. Okay, so if I select, it becomes green in color. Okay. All right. So once the curve has been created, now I need to create a slab. Okay. So for that, what I can do is go to Archicad and then design. Under design subcategory, you can see the slab here. Okay. So here I'm going to pass this closed polygon, which is a curve, to this polygon, and then you'll be able to see a slab there. And also in 3D, you can see the slab that is covering the polyline curve that we have just created. Okay. All right. So now we have created the slab. Now we go ahead and create a wall. So again, for that, you need to use the wall under the design in Archicad and then just put it inside. And then now you can just pass this curve inside the curve to the input of the curve for the wall component. You can see immediately the wall has been created. So say for example, if this wall is created in the default settings. So if you want to have a different settings, you can use the wall settings here and then pass this value to the wall settings. And then from here, you can choose a different, for example, if I want to use a different composite, just right click here and then set one composite, you will be able to find a different one. So let me just make it 100 block double cluster. So you can see the changes immediately in Archicad. Okay. So if you want to change any layer or home story, the ID, the function, structural function, everything can be changed using this wall settings. Okay. So now the slab and wall has been created. Now I want to place the columns on the corners of the curve. Okay. So if you want to place the columns on the corners, as we have seen in the assignment, so what you can do is you have to go to the curve here. So under curve, under analysis, I'm getting the control points. So the control point of our curve is all the corner points. Okay, so I'm just passing it to the curve, and then you can see when I select it, the corner points here become green in color. Okay, the four corner points get selected and they become green in color. Okay, so these are the point outputs that we are getting. So we need to place columns in that location, right? So again, we need to go to Archicad and then under the design, bring in column component. Okay, so now you can just input the points to the anchor point. Okay, so once it is done, you can see the columns inside here. Say for example, if you want to change the height of this, what you can do is we have the vector here, right? So under vector, we have points. We can take the deconstruct point. Okay, so from this point, I'm trying to get the x, y, and z values of this. Okay, and then if I want to add this z value with 3 meter, what I can do is I can use the input slider, the number slider. Okay, I just bring it inside and then I change this to column height. Okay, so this will decide my column's height. Now I need to add these two values. So the z value of the bottom point of the column will be added with this column's height. So here I need to change it to maybe zero point 0.5 to 6 meter or something. So let me just make the default value as 3 meter. Click OK. Okay, now I need to add these two add the z value with the column height. So I'm going to go maths and then bringing in the addition. Okay, so just connect these two and then you will get a result. Okay, so let me show you the result. So the result is 3 meters for all the 4 columns. Okay, so now I need to create a new point. For that I'm going to vector and then I'm going to use the construct point. Okay, so now I'm going to pass the x value of the previous point and also the y value. But now in this point, I'm going to change the z value, which is the newly created point. Okay, so I can just pass this newly created point to the end point, which will decide the height of the column. So now if you can see here, it is 3 meter. Earlier it was not 3 meter. Okay, so now if I change this value here, you can see it is changing the height of my column. So basically what I'm doing is I'm getting the bottom point of the column and then I'm getting the x, y, z value. With the z value, that is the vertical axis, I'm adding a value which will have the end point of the column, that is the top point. Okay, so once I get the top point, I can pass it to the end point of my column component. It will create accordingly the height of the column. So let me just put it back to 3 meter. You can see it creates exactly the 3 meter column. Okay, all right, now we have just created the columns just by placing at the corner points. One more thing you can do is you can use this curve and then divide the curve into multiple points, and then you can place the columns at the junction point on the divisions. Okay, so that is possible. So let's try to do that. So let me just delete everything. So now the column will be deleted immediately in Archicad also. So what I'm going to do is go to curve. I need to search for divide curve. Okay, so one more way to search components very easily is just double click and then you can search for it. So I can search divide and then you can see the divide curve here. So let me just pass it here and then the counts. Currently the default count is 10, but I can change the count to anything from using the slider here. Let me change it to a natural number, which is the integer, and then make it like 16 or something, and then pass this to the count here. And then again, I bring back the column design, and then I'm passing the divided points. So if I select, you can see the divided points in green color. Okay, and then I'm passing it to the anchor point. You can see the columns being created around. Okay, so this is the divide curve node that you can use in many locations, many applications. Okay, all right, so having seen the assignment, we will go to the next topic, which is our sun shading device. So I'm going to create a sun shading device, something like this, which will change the orientation according to the sun's azimuth. Okay, so but before going that, you guys need to install the ladybug plugin inside Grasshopper. So you can just scan this QR code and go to this link, and then there will be a installation video, YouTube video. You can watch the video and then install ladybug in your machines. So I'm not going to show you how to install it. I will just directly show you the example that we are going to work now on. Okay, so let me just use the same one and delete everything. So once I delete, you can see everything gets deleted in Archicad also. Okay, so before going into Grasshopper, let me go to the ground floor here. and then delete this polyline square rectangular one. I just use the polyline tool again, and now I want to create a straight line for my sun shading device. Okay, so I can just create a 4 meter one. Okay, so once I create this, I can go here again. Let me just drag and drop the polyline to the curve and then set it from Archicad. Okay, right. So now it is set. I need to convert this to a grasshopper curve. So let me just convert this. So this is going to be the bottom line of my sun shading device. Okay, so now I need to move this to define the top of my sun shading device. So for defining the top of my sun shading device, I need to have a height, right? So for that, I'm going to use a number slider. Okay, so again, I need to go double click and then go to the number slider settings, and then I need to change height. Okay, and then I make it let it be a real number, and then I change the minimum bound to be 0.5, and then the maximum bound to be like 6 meter or something, and then let's have a height of 3 meters in default. Okay, and click OK. So now I need to move this curve to a 3 meter height. Okay, so which will define the top of my sun shading device. So for that, I need to use a move node. So just double click on the canvas inside and then type move. Okay, so the geometry that I'm going to move is my curve here. So I pass my geometry inside, and then I need to move in Z direction, right? So for that, I need to use the vector here. Under the vector, you will have unit Z. Okay, so just drag and drop it inside. I am connecting my height with the unit Z. So this will multiply with the unit Z, and then I can pass it inside the motion. So once I pass it, you can see there are two curves here. One is the bottom curve. If I select, you'll be able to see it in green. This is the bottom one, and the moved one is the top one. There are two curves inside my grasshopper currently. Okay. All right. So if I change the slider here, you'll be able to see it is moving. Okay, so let me just make it any value currently. All right, so now I've defined my top and bottom of my sun shading device. Okay, so I need to create a beam, or I'm going to use a beam tool to create the holders on the top and the bottom. Okay, so here I have the beam tool. I can just drag and drop from the design, and then I can pass this curve. Okay, so once I pass the first curve, you can see the beam here, and you can also see it on Archicad. Okay, so let me just go to 3D here. Yeah, you can see the beam here. And again, when I pass the moved curve, which is this geometry, and then I'm using the shift key, holding down the shift key to input two inputs into the same node. Okay, so if you see here, if I just input it without clicking my shift key, it will remove the previous input and just put one inside. So in order to put multiple inputs inside, just click your shift key and then put it inside the input. Okay, so if I zoom out, you'll be able to see both the beams. So now in order to change the size of these beams, I'm going to use the beam settings here. So under Archicad, beam settings, just drag and drop it here, and then you can connect this beam settings here. Okay, so now here we have height and width. So in order to change the height and width, again we can use the number slider. Okay, so this is going to be our holder. So I can just name it as holder thickness or something, and then let me make it 0.012, maybe like 0.5. and the default value could be like 0.1 or something. Okay, so I pass it to the height. You can see the height gets changed. Okay, so if I move the slider, you'll be able to see the height gets increased, which is the thickness of our holder. Okay, so let it be like that. And let me just copy this, Control C and Control V, and then place it one more time, and then change this to holder width or something. Okay, just click OK, and then let me make this to 0.2, and then send it to the width node. Okay, so now I can control my width using this. So you can see the changes immediately there. Okay, so now both my top and bottom holders are created. So now I have to just use this curves and then divide them and then place my fins in between. Okay, so I have the bottom curve and then the top curve that we created by moving the bottom curve. Okay, so let's go again, go ahead and then divide the curve. So just double click and then type divide curve. So I want twice. So the first one, input your bottom curve, and on the second one, input your moved curve, which is the top curve. Okay. So now you can see there are points on the bottom and top, which are divided based on the count here. Okay. So this count we can give as an input also the number of divisions. So again, when you're giving a number input, we are going to use the number slider and then drag and drop it here. So let me just put number of fins. Okay, the number of fins will always be real number. So I'm going to use the integer number type, and then let me make it 5 to maybe like 30 or something. And then let the default value be like around 8 or something. Okay. And then I can pass this count to both the inputs here to the divide curve. So if I change the value here, you can see based on that, the number of divisions will be created. Okay. All right, so now we have the bottom point and then the top point. So we are going to use column tool to create the fins. Okay, so for creating column, just go to the Archicad and under design, just drag and drop the column tool there. So when you input the bottom point as the anchor point and then the top points as the end point, you can see the fins getting created there. Okay, so now I need to input the column settings here. So again, for that, go to the settings node here, settings category here, and then under column settings, just drag and drop it here. Okay, so let me connect this column settings here to the column node as an input. Okay, currently it's all default, but now we are going to change the depth and the width. So for changing the depth, that is the thickness of the fin, I'm going to use the slider again. Okay, so just drag and drop it here and then change the name to fin thickness. Okay, so I can give maybe like 0.1 or something and then pass it to the depth. Okay, you can see the depth got changed. Now, in order to find the width of the column, I'm going to use a formula which will be calculated by dividing the length of the curve with the number of the fins. Okay, so for that I need to use division node. So A by B, which is the division node, I'm just dragging and dropping it inside. Okay, now I need to have the curve's length. Okay, so for finding the curve's length, just double click and then type curve length. Okay, so this is the curve's length. This will measure the length of a curve. Okay, so just bring it inside your canvas and then connect your curve input. Okay, so now you'll be able to get the length of the curve. So let me just see, the length of the curve is 4 meter currently. Okay, so I can just input it inside the division A and then the number of pins as denominator here. Okay, so I will get a result Let me check the result here. Using the panel, you can see it's 0.57. Okay, so this is my width of the panel or the fin. Okay, so let me just input it inside the width. So you can see it is closing entirely. Okay, so irrespective of the number of divisions, it will automatically calculate the width of the fin when I change, and then it will automatically give the width of the fin perfectly fine. Okay, so let me just make it 9 for now. Okay, the last thing that I want to show here on this is the rotation angle. Okay, so for rotation angle, you can again use a number slider. Okay, so just use the number slider and then I will give the rotation angle here. And then let me make it a real number and then have a value until 90 degree. Okay, and then click OK. So you can just connect this to rotation angle. And then when I change the angle here, you can see the pins will be rotating also. Okay, so when I make it 90, it rotates automatically. Okay, so if I change the fins thickness here, everything will be reflected immediately in your Archicad. So the number of fins, let me change. So if I increase the number of fins, the fins width is automatically calculated based on the formula that we just used here. That is the division formula. So I'm dividing the length of the curve with the number of fins to get the width of the fin. Okay. All right. So now we are just using a manual angle here to do the rotation. What if we are using sun's azimuth based on the location of your project? So we are going to use Ladybug for that. Once you install Ladybug, you'll be able to find all these components inside. So I'll just try to finish it fast. It's not very. I'm not going to go into detail of Ladybug, just like to do the sun study or something. I'm here just going to get the location of the project, and then from the location I'm going to get the sun's angle, and then I'm going to pass that angle inside the rotation here. Okay, so we also have a session for doing the sun study, which is the last session of this webinar series. So this one is just going to be very simple. Okay, so let me just bring in the nodes components that are required to get the sun's azimuth. So we need to have the weather location. Okay, so let me just drag and drop it here. Okay, if you see here, I need to give the weather URL of your project. Okay, so for that, let me show you guys how to do that. Okay, so just go to Google and then search for Ladybug weather URL. Okay, so once you search that, you can see this EPW map. So just open that and then you can zoom into the location of your project. So let's just go to Singapore, and then this location information is basically available on the airports generally. So let's just use the PyLabor one, and then click that. You'll be able to copy link to the clipboard. Okay, so I've copied the link. Let me just go back to Rhino, and then I need to put this inside a panel. Just double click this and then control V. I pasted the copied URL and then I'm passing it inside the weather URL. Okay, so now the EPW file is created. I need to go to Ladybug again and I need to import the location from the EPW file. Okay, so let's just drag and drop it here and then pass the EPW file here to pass the location or create the location. So once the location is created, let me just move it some. Okay, so the location is created now. So now I need to get the sun of this location. Okay, sun's location. Okay, so just input this sun path and then drop it inside the canvas. So you can pass the location inside here. Okay, now I need to enter the sun analysis period. Say for example, any specific time. Okay, so let me just drag and drop this sun analysis LB analysis period. And then if you see here, we can input the month, day, and hour of our analysis. So again, for that, we can use the sliders. So let me just bring in the slider here and then make it month and then the real number. So month is going to be 1 to 12, right? So just make it 1 to 12 and then you can choose any month that you want to study and then pass it to the month. And I'm going to pass it to the end month also because my study is going to be at any instance. So it's just same month. And then I can just copy this and paste it again to make it day. So day should be from 1 to 31st, any day. So I can just choose any day by default, like I make it 10 or something. Okay, and then you can pass it to the start day and the end day. Okay, so now the time at any time, that is the hour. So for that, you can just copy and paste again and then change this to hour. Okay, so hour is going to be 0 to 23. Okay, so if you hover over the inputs here, it will show you what should be the input. Okay, so the end day should be 1 to 31. The month should be 1 to 12. So you can just hover and decide what should be the input. Okay, so let me just enter the hour and then from here I get the hoist. So I can just input this hoist inside the sun path hoist input. Okay, so now if you see here, there are multiple outputs. The output that we are concerned is the azimuth of the location. Okay, so currently I also have to enter the start hour, right? So I missed entering it to the start hour. Okay, now if I go and see, I will just get only one output, which is 80.39. So if you want to check it, just input a panel, bring a panel inside, and you can see the angle. Okay, now just let me zoom out inside the Rhino. You'll be able to see a hemisphere here. So you can see the sun's exact location. Okay, so this point is the sun's location. Let me just zoom out, and then if I move the hover, you can see the sun moving in the other direction. Okay, so I'm going to study at, like, say for example 12 p.m. or something. What I can do is I need to input this azimuth angle inside the rotation angle. But before that, I need to change the direction. Basically, why I'm changing the direction is in my object that I created, when I change the angle, it will rotate in anti-clockwise direction. But this sun's movement is in clockwise direction generally, so I need to convert this angle to rotate in anti-clockwise direction. So for that, I'm going to use uh, just minus 180 with the angle that we get from here. Okay, so for that, I need to input an angle. So for input the number, I just use the number icon here, number component here, and then right click, you can set the number there. Make it minus 180, and then you can commit the changes, and then I'm putting it inside B. Okay, so now if I check the result, it is minus 112. Okay, so again now I need to make this negative, convert this, multiply this with negative value minus 1, and then I can pass it to the rotation angle as a positive value. Okay, so for that, just connect the result with the value and make it positive. So if I want to check the panel, you can see it gets converted to plus 112, and then I can pass this to the rotation angle here. Okay, so I'm just deleting this rotation angle which we use manually. So you can see this. So if you change the hour, you can see the sun's angle getting changed here. Okay, the fins getting changed there. Okay, so that's all for today. So the next week, we will try to do some twisted tower and also some roofs, triangulated roofs, and then try to schedule it inside Archicad. So if you guys are able to create a twisted tower by yourself, say for example, I will just try to send these steps that you can use to create the twisted tower by just drawing a polyline inside Archicad, and then use that polyline to create the twisted tower. I will send you the assignments. Probably you'll be able to try it yourself, but if you're not able to complete it, maybe I can show you in the next session. Okay, so let me go back to the slides. So follow us on our YouTube channels from Facebook and LinkedIn also. So we will be posting all the recordings of this video on the YouTube channel. So you can watch the videos to follow the examples that we are presenting here. Okay, so if you have any questions, you can just mail to me. Right, Q&A, open to Q&A. If you guys have any questions, you can post or you can unmute and ask yourself. Yeah. I can see some of the questions already. I think Chidam is helping to answer those questions. Thank you, Chidam.
Thanks, Vimoya. Andrea is asking, can we have a broad recap on the Grasshopper code?
Sure.
I think you can make a full screen of the Grasshopper code and then.
Yeah. All right. So yeah. So first, basically, what I did is I just created a 2D curve, which is the straight line inside my Archicad, and then I converted that curve into a Rhino curve. Okay. So Archicad curve, I brought it from here, and then the Rhino curve is inside the Pyrams curve. Okay. So this is the difference between the Archicad curve and then the Rhino curve. Okay, so once I convert that curve into a Rhino curve, I can do multiple things, like I can move the geometry, I can divide the curve into multiple points. All that I can perform all those operations. So that's why I converted that Archicad curve into a Rhino curve. So once after the curve has been created, I need to move to define the top of my sun shading device. Okay, so for that I just use the move node to move it. For defining the direction, that is the vertical direction, I'm using this unit Z, and then for defining the height, I'm passing the height here. So whatever changes I do here, it will reflect the height of my sun shading device. So if you see here, so I just made it smaller, 1.5, so its height is reduced. Okay, so now I have two curves. One is the bottom curve and the top curve. So now I need to create beams. I'm going to use the beam tool to create the holders of my sun shading device. So for creating the holders, I'm using the beam node component. And then I'm just passing these curves inside to create the holders. So in order to control the size of my beam, I'm using the beam settings and then the sliders to control the height and width of the beam. Okay, the height and width of the profile. So the length is controlled by the curve here that I pass. The height and width is controlled by the sliders here. All right, so now the holder is created. Now I have to create the fins. So for creating the fins, I'm going to use the column tool. So column tool, I need to enter the anchoring point, that is the bottom point, and the end point, which is the top point. Okay, so I have two curves. One is defining the bottom and the other one is defining the top. So I can divide these two curves uh, into a number of divisions, which I can enter. Okay, so here I can just enter the divisions uh, using the slider here, and then I can divide those points. So I have the bottom points, that is divided by dividing the curve in the bottom, and then I have the top points by dividing the curve at the top. So I can input these points again inside. Okay, so the column has been created, which is the fin in this example. Okay, again to control the size of the fins, I'm using the column settings. Again, for the column settings, I need to define the depth, that is the thickness of the fin, and also the width of the fin. The width of the fin is going to change based on the number of divisions that I give. Okay, so based on the number of division, meaning I need to divide the length of the curve divided by the number of divisions, so I will get the width of each fin. Okay, so that is what I'm doing here, and then passing it to the width node. Okay, and then the fin thickness is again a slider input. Anybody, we can just change it and change the thickness of the fin. So now we have created our device. So now we need to make it responsive to the sun. So for that we are going to use Ladybug tool. Okay, so we are using Ladybug components, and then first I decided a location in the URL that I showed you guys, and then from there I'm getting the URL of the project location, and then I'm converting it into a Rhino location here. Okay, into a format which Rhino can process. Okay, after that, in the sun path, I'm bringing in the sun path component. I need to enter the analysis period. Say for example, it's going to be 1 month, any of the months, and in that month I'm going to choose one day, and in that day I need to choose 1 hour or one particular time where I can do the sun study of the device. Okay, so if you see here, under hoist I can just get this output and then input it in the sun path, which will send my analysis period based on the slider that I input here. Okay, after that I'm getting the sun's azimuth, which is the angle of the sun with respect to the project location. Okay, so I'm converting that into a positive direction in order to have because the value that I get here is anti-clockwise. I mean, sorry, clockwise. So I need to convert it into anti-clockwise and then pass it inside the rotation angle of my column, so which will adjust the rotation. Okay, so this is the short recap of what we did. Okay, any other questions? How to save the work after that? We need to separate Rhino Grasshopper and Archicad. Okay, so basically you can just go here and then save your Grasshopper file, and then you just need to open the Grasshopper and Archicad at the same time, and then when you open, this one will be something like this. So it will not be having any value, so it will show you a warning that there is no curve being linked to Archicad. So you need to create your curve inside Archicad and then come here under Grasshopper and then just right click and set one 2D curve in Archicad. So on Archicad and go to 2D. Just give me a minute. Yeah, I can choose. So it automatically removes all your warnings. So this way you can save and then open them and then recreate your recipe that can create components inside Archicad. Catherine, yeah, we will be sending you the homework sheet along with the steps and instructions to follow. Yeah.
Yeah, well, just to add to the saving of the files, we basically need to save only the Grasshopper and Archicad file, right? So during the work, Rhino, we are not creating anything in Rhino, so we don't need to save the Rhino file, right? Every time when we we want to edit the Grasshopper code, we just run a new Rhino file and open this Grasshopper file, then we can continue, right?
Yeah,
So it is
basically you can,
just two files,
yeah,
yeah?
basically you can double click the file, it will automatically open Rhino and then it will come to the Grasshopper.
Yeah,
So
yeah. Thanks. Yeah, I just want to add that. Yeah.
yeah.
Thanks for the team. Yeah.
Sure.
Thanks, Catherine.
Hey, Chidam, does
Yep.
that mean that after, because I've downloaded the 90-day free evaluation version, so we don't need to save in Rhino, does that mean I just continue using the evaluation version even after 90 days?
No, it won't be able to run after the evaluation period. So
But
it's
because it says it will be functioning, but just cannot save. But if I don't need to save, can I still use it?
We'll have a issue. Yeah, you can't run. Yeah.
Find out after 90 days.
Yeah.
Okay. Okay, thanks.
Yeah.
Okay,
So any other?
go. Thanks a lot.
No problem. Thank you. Any other questions?